Welcome to the world of ReactJS hooks, where functional components reign supreme. Let's dive into useState, a fundamental hook that revolutionizes state management in React. Here, we're creating a counter component. With useState, we declare a state variable count, initializing it to 0. The setCount function lets us update this state, ensuring our UI re-renders with the new value. By clicking the button, we increment count, demonstrating the simplicity and power of useState in managing component state. In ReactJS, useEffect is a versatile hook that replaces lifecycle methods for functional components. Let's look at this user data component. We're fetching data from an API, a typical use case for useEffect. It runs after every render by default, but here, we've provided an empty dependency array, ensuring it runs only once after the initial render. This mimics the behavior of component hidmount in class components, illustrating useEffect's role in side effects management like data fetching, subscriptions, or manually changing the DOM. Even the most powerful tools have their pitfalls. A common mistake with useEffect is forgetting the dependency array or getting it wrong. In this incorrect implementation, we've set up a timer, but there's no cleanup. This can lead to memory leaks. In the corrected version, we return a function that clears the interval, ensuring our component cleans up after itself. Remember, useEffect should always handle its side effects, both during and after their execution. Context in ReactJS provides a way to pass data through the component tree without having to pass props down manually at every level. With useContext, accessing this data becomes incredibly straightforward. In this example, we're using a theme context to style our themed button component. useContext allows us to consume this context's value with minimal boilerplate, demonstrating how hooks simplify previously complex patterns in React. However, useContext isn't without its caveats. Overusing it, especially with high-frequency updates, can lead to performance issues. When a context value changes, all components consuming it re-render. If not managed carefully, this can cause unnecessary re-renders, impacting performance. It's crucial to be mindful of context usage patterns and opt for local state or other optimizations where possible. ReactJS allows us to create our own hooks, unlocking the door to reusable stateful logic. Here, we're crafting a useForm hook, encapsulating the logic for handling form inputs. By separating this logic into a custom hook, we make our form component cleaner and our code more reusable. Notice how useForm returns the form values and a handle change function, abstracting away the complexity and making form handling a breeze. ReactJS predominantly embraces a declarative approach to handling the DOM, but sometimes you need to escape this pattern. That's where useRef comes in. In this autofocus input component, useRef gives us direct access to a DOM element, allowing us to set focus on an input field when the component mounts. Unlike state, changing a ref doesn't trigger a re-render, making it perfect for this kind of impermanent, uncontrolled behavior. Performance optimization is crucial in any application. useCallback is a hook that can help in this regard, especially when dealing with inline callback functions. It returns a memoized version of the callback that only changes if one of its dependencies changes. In this example, we've used useCallback to ensure our increment function doesn't get recreated unless necessary, preventing unnecessary renders and improving performance, especially in complex components. Similar to useCallback, useMemo is all about optimization. It memoizes expensive calculations and only recomputes them when one of their dependencies changes. Here, we're using useMemo to avoid recalculating an expensive function on every render, which can be a game changer in performance-critical applications. It's a great example of how React hooks can be used to improve both developer experience and app performance. ReactJS hooks come with a set of rules that are essential for their correct use and functioning. One key rule is to always use hooks at the top level of your React function. This ensures that hooks are called in the same order each time a component renders, which is crucial for React to correctly preserve the state of hooks between multiple useState and useEffect calls. Another rule is to only call hooks from React functions, meaning within React functional components or custom hooks. This guarantees that all stateful logic in a component is clearly visible from its source code, maintaining the predictability and readability of your React applications. Understanding common mistakes with hooks can save you from subtle and hard-to-debug issues. A frequent error is using hooks inside loops, conditions, or nested functions. This breaks the rules of hooks, leading to unpredictable behaviors. For example, wrapping a useEffect inside an if statement might seem logical, but it goes against React's design and can cause bugs. The correct approach is to use the hook at the top level and then place your conditional logic inside the hook. By sticking to these patterns, you ensure your hooks work seamlessly, making your React components more reliable and maintainable.